Well, good afternoon. My name is Dr Abdulkin. I'm the head of materials for the Black Trace Group. And what we have here is an Asia flow chemistry system producing gold nanoparticles. So let me just show you very quickly the setup, and then I'll tell you exactly why we're using the Asia flow chemistry setup rather than a batch chemistry setup in order to produce those gold nanoparticles. So first of all, we have a solution of a gold precursor, which happens to be hydrogen tetrachloroaurate in this case, and we have our reducing agent and a cathode agent at the same time. This is the sodium citrate. And what we're doing here is we're using our Asia pump to pump two reagents at a set flow rate. They then go through a reaction injection module, and then critically they are flown separately and are combined in a Cirrus micromixer chip. And what this enables us to do is combine the two reagents very, very quickly and very, very precisely. What happens afterwards is that the two reagents are flown into our tube reactor, in which we're controlling the temperature precisely and the residence time precisely. And then they're flown through a pressure control unit, and then we're collecting them on the back end. Now, this enables us to do a number of things over a typical batch chemistry setup. First of all, it enables us to control molar ratios of the two reagents precisely. What you will end up doing, inevitably, if you are making a batch chemistry reaction, is you'll start adding one reagent into the other as you're mixing them. And this will create concentration gradients. This will also create temperature gradients as your mixing is imperfect and slow. And if you have a range of conditions, you will end up with a range of particle sizes. That is not so in the flow chemistry setup, because, as we've already demonstrated, the mixing is fast, the conditions are well controlled at each step. So what we can do is, just by changing the molar ratio of the two reagents in very, very tiny quantities, we can control the particle size and consequently the particle color, or the color of the solution of these gold nanoparticles. We can also change the residence time, i.e. the time they spend in the reactor, and thus obtain this progression of colors here. This is 10 minutes, 15, 20, 30, 40, and finally 60. And then another clever bit that flow chemistry enables us to do is it enables us to control the pressure on the back end. That means we can pressurize the entire system, and that means we can use temperatures that far exceed those available to the standard batch chemistry reactor. So for example, at the moment, we're using a reduction of gold salt in water at 123 degrees centigrade. And that enables us to nucleate our particles much quicker, and that enables us to produce those particles with unprecedented levels of non-dispersity. And this is a quick overview of an Asia flow system and production of gold nanoparticles. Thank you.